Hi everyone, welcome to E-Content Development Center, Majlis Arts and Science College, Puramannur. This is Bijitra, Assistant Professor, Department of Computer Science. In this video, I will introduce you to the concept of file system in operating system. After this video, you will be able to define file and file system, what are the attributes of file system and operations on files, file access mechanisms and file allocation mechanisms. Let's get started. What is a file? File is a collection of related informations that are recorded on secondary storage like magnetic tape, magnetic disk or optical disk. The files are divided into logical blocks. That blocks are stored in the disk. Next is file system. File system is a software that is stored in the OS kernel. The file system manages all the user files on the device. The collection of files are known as directories, and the collection of directories in different levels are known as file system. The next one is attributes of a file. The important attributes of a files are name, identifier, type, location, size, protection and time and date. The first one is name. Name attributes contain the file name. It is human readable form. Next is identifier. Each file has a unique tag or unique ID. Next is type. Type indicates the type of the file. For example, .txt indicates it's a text file, .doc indicates it's a word file, etc. Next is location. Location pointer to the file location on device. Size indicates the current size of the file. Protection attributes contain the controls and assign the power of reading, writing and executing. The last attribute is time and date, that contain this information might be kept for the creation of the file, its last modification and last used. Next is file operations. Creation, writing, reading, repositioning, deleting and truncating are the operations on files. First one is creating. Creating means to create a new file. To create a file, two steps necessary for creating a file. First one is space in the file system and the next one is entry for the new file must be made in the directory. Next is writing a file. To write to a file, you make a system call to specify about the file name along with the information. Next is reading a file. To read from a file, you use a system call which specifies the name of the file and where within memory the next block of the file should be placed. Next operation is repositioning. The directory is then searched for the suitable entry and the current file position pointer is relocating to a given value. Relocating within a file need not require any actual input-output. The file operation is also known as file seek. Next is deleting a file. Deleting operation means to delete the content of the file and also the attributes of the file. So the memory space is releasing and the other file reuse that space. Next is truncating. Truncating means to delete the content of the file but not in the attribute. Next topic is file access mechanisms. File access mechanism refers to the manner in which the records of a file may be accessed. The file access mechanisms are divided into three types: sequential, direct or random and indexed sequential. Next is direct or random access. In this case, the file records are accessed directly. Each record has its own address on the file with by the help of which it can be directly accessed for reading or writing. The records need not be in any sequence within the file and they need not be in adjacent locations on the storage medium. The next is indexed sequential access. Indexed sequential access is based on sequential access. Each file contains a separate index block. That block contains the pointer values. Index is searched sequentially and the pointer is used to access the file directly. Next topic is file allocation methods. File allocation methods define how the files are stored in the disk. There are two types of file allocation methods, contiguous allocation and non-contiguous allocation. The main idea behind this method is to provide efficient disk space utilization and fast access. There are two types of file allocation methods, contiguous allocation and non-contiguous allocation. The non-contiguous allocation is again divided into two types, indexed allocation and linked allocation. The first one is contiguous allocation. In this case, the blocks are stored in the disk in a continuous manner. For example, if a file requires n blocks and is given a block B as the starting location, then the block assigned to the file B, B plus 1, B plus 2, etc. B plus n minus 1. In the contiguous allocation, the directory contains the file name, starting address of the block and the length of the allocated blocks. In this case, count, tr, mail, list, f are the files. First one is count. Count file, the starting block address is 0 and the length is 2. In the disk allocation, the count file is stored in the 0 and 1 block, that is continuous manner. Next is tr. tr is a file, starting block address is 14 and the length is 3. Then in the disk, tr is stored in the blocks 14, 15 and 16. Next file is mail, that the starting block address is 19 and the length is 6. In the disk allocation, the mail file is stored in the 19 to 24 blocks. Next is list file, the starting block address is 28 and the length is 4. Then the list file is stored in the location 28, 29, 30 and 31 blocks. Last one is f, that is the starting location of the block is 6 and the length is 2. Then in the disk allocation, f is stored in the blocks 6 and 7. Next is advantages of contiguous allocation. Contiguous allocation support sequential and direct access mechanisms, and it is very fast since the number of seeks are minimum in the case of contiguous allocation. Next is disadvantages. This method suffers from internal and external fragmentation, and increasing the size of file is difficult because it depends on the availability of contiguous memory at a particular instance. Next is linked list allocation. In this scheme, each file is a linked list of disk block which need not be contiguous. The disk blocks can be scattered anywhere on the disk. In the linked allocation, the directory contains the file name, starting block address and ending block address of the file. For example, in a file zip, the starting block address is 9 and ending block address is 25. In this case, each block contains a pointer value that points to the next block. The last block contains the pointer value is -1 or null, that indicates the end of the file. In this example, the directory contains the file name zip and the starting block is 9 and the ending block is 25. In the disk allocation, the starting block is 9 that contain the pointer value to the next block, that is 16. 16 contain the next block, that is 1. 1 contain the next block, that is 10. 10 contains the next block, that is 25. 25 contain the pointer value -1, that indicates the end of the file. Next, advantages of linked allocation. The first advantage is it does not suffer external fragmentation, and this is very flexible in terms of file size. File size can be increased easily since the system does not have to look for a contiguous chunk of memory. Disadvantages. The first disadvantage of linked allocation is the file blocks are distributed randomly on the disk. The large number of seeks are needed. So, this makes linked allocation slower. The next one is it does not support random or direct access. We cannot directly access the block of a file. Next is pointer required in the linked allocation require extra memory space. Next is indexed allocation. In this case, each file contains an index block. Index block contains all the pointers in the file. Each file has its own index block. In this case, the directory contains the file name and index block address. In this example, the file zip, the index block address is 19. In the disk allocation, the 19th block contains all the pointer to the blocks on the file. That is 19 contain the pointer value 10, 1, 9, 16 and 25. Next is advantages of indexed allocation. It overcomes the problem of external fragmentation and this support direct access to the blocks occupied by the file and therefore provides fast access to the file blocks. Next, disadvantages. The pointer overhead for indexed allocation is greater than linked allocation. For example, for a very small files, say files that expand only 2-3 blocks, the indexed allocation would keep one entire block for the pointers, which is inefficient in terms of memory utilization. That's all. I hope all of you get an idea about file system in the operating system. We will meet with you in the next video. Thank you.